All right. How's it going, everybody? Today we're going to be doing notes section 1.3, writing linear equations. So, based on information that they give us, mostly a point and a slope, we're going to be writing the equation of a line. Now, there's two different types of formulas we're going to be using, so we have to be able to tell them apart. Now, I know it says work with a partner, but it being Monday, we need to make sure we get started right away. So it says match each description of the situation with its corresponding graph, and of course, explain your reasoning. So now check this out. It says a person gives $20 per week to a friend to repay a $200 loan. Now remember, once he pays $20 one week, 20 the next, 20 the next, eventually it has to end at 200, right? Or actually the balance would be zero at that point. So in this case, when we're looking at it, the y-intercept in this case is $200, and the line decreases because when the loan began, it was $200, but we know eventually you're going to pay $20 every week, and eventually you won't owe any money. So when we're looking at the lines here, we notice that for B, check this out right here, it starts at 200 and it's decreasing, and eventually, why did it stop here? Because that's a value of zero, meaning you don't owe any money anymore. Now it's a little bit tough to tell how much the drop is because of the numbers that we're using, but there's no other graph that would begin at 200, so we know the answer would be B. Now, for the next one, of course, it says an employee receives $12.50 per hour plus $2 for each unit produced per hour. So now, here in this case, if they make more units as they go along, we know that they're going to earn more. So the idea is the y-intercept, where it all begins, is the 1250. And then the line has a positive slope. And the reason we know it has a positive slope is because if they produce a couple more units, depending on how many they make, it's an extra $2 per hour. So we know that there can be an increase. So when we look at our graphs, well, first of all, that's why we start with the y-intercept at all times. We're looking for 1250. See, these don't make any sense. This is more than 20. 800 is ridiculous. This is right above the 10. So this is where we're looking at the 12.5 start. And then if you notice, it just starts to climb, depending, of course, on how many units they create. So our graph would be C. Now, for the third one here, it says a sales representative receives $30 per day for food plus well, 56.5, I guess, cents for each mile driven. But we know that for the start, we know they're automatically going to get $30 per day. And they'll make a little extra, of course. So in this case, the y-intercept is 30. And once again, line increases. So it's going to get bigger. It's got to have a positive slope, of course. But the idea is we know, well, they're automatically getting 30 per day plus a little extra if they, depending on how many miles they drive. So again, we're looking for one that starts at 30. So we see graph A here between the 20 and the 40. So that's definitely the 30 start. And yeah, that's not a lot, right? Like 56 cents, just about 56 and a half cents. That's why the climb, look at this, it increases very slowly. So in this case, A would be the answer for this one. And of course, by process of elimination, we already know this one has to be D. It's the only graph that hasn't been used. But check this out. It says a computer was produced for $750, but it depreciates $100 per year. Remember, depreciation means it's dropping in price or in value in this case. And so the y-intercept would be 750 because that's the most this thing is worth, but then it's going to start dropping by 100 per year. So the y-intercept is 750 and the line decreases, which of course, when we see the graph here for letter D, look at that. And I know it looks like it's right at 800, but it's technically just under. So that's probably the 750. And then we see the drop. And notice this one does end. Remember, the value of your computer can't be in the negative amount. You're not going to owe somebody anything. It's just not worth anything anymore. That's why it stops right at zero. But anyways, this is just to kind of get the idea of, all right, y-intercept is important. Trying to figure out if a line increases, which would be a positive slope. If a line decreases, it would be a negative slope. These are the kind of things that we're looking at when we're thinking about lines. And so now it's time, all right, it's time to discuss here what the forms of an equation of a line are. So there are two forms for the equation of a line. Now, this one we talked about the other day, the slope-intercept form. Remember, the y is by itself. This is how we recognize slope-intercept form. We also talk about what every little letter represents. So, for instance, the m, we already know is the slope. And when we talk about slope, we're talking about rise over run. And the b value, as we mentioned last week, is our y-intercept. And because we're doing a y-intercept, remember, it technically is a point, and the point would be 0, comma b. As we found last week, the x must be 0. Right? When we're trying to find the y-intercept, our x value has to be a 0. So it's a point that we're graphing. And of course, we were using this when we were graphing, but we also can use this to create an equation of a line. Now, unfortunately, we don't get lucky, and they don't always give us the y-intercept. If they do, this is the form that I can go straight to and be done with the problem. But most of the time, they're going to give you a slope, or we'll find it. But most of the time, they're just going to give you some other random point that your line goes through. And so when they give us something like this, we use what we call the point slope formula. Now, in the point slope formula, it says y minus y1. This is what you're actually going to fill in with the number. It also says is equal to the slope. This is a value we will fill in. Parentheses, x minus x sub 1. The three things that I highlighted, I didn't highlight the entire thing. I didn't want to do that. But the three things that are highlighted, that's where you're actually going to plug in values. See, we have a point, right? It could be any random point. We're going to call it x1, y1. And so look, we have a spot for all of these values. This will go here. This one goes over here, right? The y with the y, the x with the x. And of course, this is our slope, just like before. So then that's what gets plugged in. So three values get plugged in. And we have to bring up the fact, of course, that yes, that x and the y and the minus signs, they're a part of the formula. They have to be there when you start. Eventually, with the work you do, it might change, but they need to be there from the beginning. And finally, just in case they don't give you a slope, right? So here they have to give you a slope. Here they have to give you a slope. But what if they don't? What if they give me a graph instead of giving me a slope? Then I have to do the work to find it. So we have what we call the slope formula. Now, the slope formula, again, it dates back to your Algebra 1 days when you're doing the slope formula. And it says your y's are on top, the x's are at the bottom. So that's the first thing we should notice. So here, let's mark it up a little bit. It's still the concept of rise over run. So these are my y's over the x's. It is still rise over run, of course. But remember, in order to use the slope formula, in order to use this, you must have 2 points. So they have to give us 2 points in order for this to work. Well, that's why when we look here, like we can create a point here and we'll call it x1 goes with y1 and x2 goes with y2. They have to give you 2 points in order for this to work. Well, let's practice that, right? Let's understand that concept a little bit better. So when you look at examples number 1 and 2, it says write a linear function f. So they want me to name it with the given values. So what we learned last week about functions is when they give you information like this, you have to remember one thing. They're just giving me a point, right? This says f of x, so there's my x, is equal to the y value. So they're giving me an x and they're giving me a y. So for instance, this one right here, this is how we write points in the function world. So it's just 4 comma -3. That's the first point that was given to us. If we look right next to it, well, they just gave me another point here to work with, right? This is our x. So we have point number 2, which is 0 comma -2. Now, you got to notice something here. Because the x is 0, we just said it earlier, right? We said it right up here. In fact, we can still see it. When your x is 0, they actually gave me a y-intercept. So if they give me a y-intercept, I can use this slope-intercept form instead. So I can finish the problem even faster. So we're going to make that little note here. Since x is equal to 0, this is a y-intercept. Which means the b value is equal to -2. So you see, if I use this formula, hey, I already have part of my problem, part of my answer. They said write an equation of a line. I have the b. Then the only thing left that I need is my slope. And so that's one that requires a little bit of work. So I need to find slope. Now remember, I do have 2 points. Look, we have the point 4 comma -3. And we have the point 0 -2. Now I like writing them one on top of the other for a reason. Here are my x's. Here are my y's. And you know what? I'm just going to go in this order. Okay. I like using the arrow method because it just kind of, well, it forces us to make less mistakes, actually. It sounds weird, but it does. Because when I do slope, it's a fraction with a minus sign. And then look, your y's are on top. So my y's are -3 and -2. Okay, well then write them in. -3. And yes, you have to put in an extra negative. That purple minus sign is part of the formula. It has to be there. Can't leave that out. And then, of course, my x's are 4 and 0. All right, keep that order going. 4 to 0. The arrows tell you what order to write them in. And yes, the arrows have to point in the same direction. All right, well, now I can actually do the work to find my slope. So in this case, my slope is, let's see, this becomes a plus. It's the only time you ever do that. -3 plus 2 is -1. And then 4 minus 0 is just 4. Well, then there's my slope. I have my b value. Well, then look, we're ready to go. I can now take these 2 pieces of information, and here's my equation. Y is equal to mx plus b. But remember, we're only going to plug in for the m and for the b value. So here's my official equation. Y equals the slope, which was -1/4. Yes, we write the x next to it because we're creating this equation of a line. And then my b value was a -2. I know it says plus, but because it's a -2, we're going to say -2. And just like that, we've created an equation of a line. But you have to remember one thing, right? They said, write me a linear function. What I have here is an equation. If I want to turn this into a function, remember what we said. When you write a function, another fancy way of saying the letter y, they said call it f, is to call it f of x, is officially -1/4x minus 2, and now it is officially a function, just like they asked. And we didn't get to name it on our own and give it any letter. No, they said call it f. And so this is the official answer. Okay? This is just creating the equation and then a little change to turn it into a function. All right. So now let's practice it one more time. This one we wrote a lot of little extra notes to kind of guide us. So let's see if we can kind of work this out a little bit faster. So here we have a function value for 5 is -1. Remember, that just means one thing. They just gave me a point. This is the point 5, -1. Then, of course, they said, hey, f of 0 is -5. In the function world, they have now given me yet another point, 0, -5. And we got lucky again. Look at that 0 right here. Because this is a 0, I already know my y-intercept, then it's official, is b is equal to -5. That's good. That's already half of what I need. The only other thing I need then is my slope. So to find my slope, here we go. All right, slope. Remember what we said earlier? I'm just going to write the points out. 5, -1, and then a little space, 0, -5. And I'm going to have my arrows heading down, and it has to be the same for both. And then look at how we use this, okay? The slope is equal to a fraction. Yes, put your minus signs automatically. They have to be there. And now let's bring in the numbers. My y's are on top. Here are my y's. -1 and -5. So I have to bring in that extra negative. Don't forget that extra negative, of course. And then, of course, it's 5, 0. So 5 and 0. All right, so here we go. The slope is officially, let's see, this is the only one we can change. -1 and 5 is 4. 5 minus 0 is 5. All right, we have a slope. We have everything we need now to create our equation of a line. Remember, I'm creating the equation first, and then just a little fix, and it's going to become a function. All right, so here we go. My equation, right? I have everything I need here. Y is equal to mx plus b. The y is here. Now my slope, we're over 5 with an x. My y-intercept is -5, so we say -5. But they wanted a function. They said, give it the name of f. So then f of x, there it is. There's the only change I have to make. And then everything else gets written down. And just like that, we have our function value. All right, so take a moment to catch up with the notes, of course. I will be posting a picture of this shortly so that you can see it up on Google Classroom. All right, so moving on to number 3, our last page here for our notes. Number 3, instead of giving us information like they did previously, where they gave me points in the function form, it says use the graph to write an equation of a line and interpret what the slope means. Also, what's domain and what's the range of each function. Now remember, domain are the x's that we're allowed to plug in. The range are the y values that we get as a result of that. So use the graph, of course. Well, remember, if you look at the graph, they have already given me 2 pieces of information. And one of them is very important here. Look at that right there. Look at that point right here. That's just not any point. That right there is the y-intercept, which means they just made things a little bit easier for me. So here's the thing. I need 2 things. I notice it's a y-intercept. So I have my y-intercept now, which is b is equal to 50. That's what my b value is. But now I need a slope. All right? This is what we're looking for when we're trying to find our slope. So let's look at our points again. The 2 points they gave me are 10, 51 and 0, 50. All right, I'm going to use that technique. That arrow technique makes the slope formula a lot easier. So this is the order I'm going to go in. So my slope, here's my fraction. Here's my 2 minus signs that automatically have to be there. All right, y's are on top, not the first numbers. The y's are on top. So 51 and 50, 51 and 50. And then my x is at the bottom, and that's a 10 and a 0. So 10 and 0. So we work this thing out. Let's see what we get. 51 minus 50 is just a 1. And 10 minus 0 is just 10. All right, I have my y-intercept. I have my slope. So technically, we have everything we need for this problem. So I'm going to take this info, and here it is. Y is equal to mx plus b. Now, they didn't say to turn it into a function, so we won't waste our time with that. But I have everything I need. Y is equal to my slope, which is 1 over 10 with an x. You got to bring in that x. And then my y-intercept was a 50. So yeah, I'm going plus 50. So there is part one. The first thing they said was write an equation of a line. There, my equation of a line has been written. But now what they wanted from me was tell me what the slope represents, right? In the context of this problem. Well, here's what you have to understand. When you're trying to figure out the slope, look at what they said. 1 over 10. But remember, it's my y's on top, the x's at the bottom. So if the y's are on top, look at what it says. It's the cost, right? In dollars. So the top is $1. And then the bottom, look at what it says. The bottom are my x's. That's why it's important to understand the order. Well, look at what the x-axis is. The number of text messages sent. So we're just going to write text so that we remember a little bit. So what is this slope really representing? The slope, it's basically saying it cost $1. There it is. To send 10, because that's the bottom number there, text messages. And that is us right there interpreting what our slope represents. But again, if you know what at the top are your y's, then look at your y-axis. Just read what it says. When you know that your x's are at the bottom, then read what the x-axis is telling us. And then this is a very loaded question. They said, hey, well, now you've done all of that. Tell me the domain and tell me the range. So remember, this is answer number 2. They want 4 things here. So now we're going to look at domain. And we're going to look at our x's, because that's what domain is. So I'm going to look at my x-axis here. So when I look at my graph, notice there's no x values below 0. There's nothing back here, so there are no negatives. But when I look at my graph, even though it's going up, that doesn't matter. Look at your x-axis. Your numbers are just getting bigger and bigger as you go this way. So that's why my domain are the x values. So I'm looking at my x-axis are any x that are greater, because they're getting bigger, or equal to 0. Why did I put an equal sign? Because I'm literally making contact right here. Look at that. There's an actual 0 in that point. Now my range. Range is, of course, a little bit different. We said the range are my y values. That's what we learned the other day. So I'm going to look at my y-axis only. I don't care about the x. So you see, this graph right here doesn't exist anywhere down here. In fact, the very first y value that it starts to exist at is 50. So I'm going to put the letter y, and I'm going to put the number 50 so far, because it's starting at 50. And then the question is, well, does my graph exist anywhere below that? No, not at all. But if I go up on my y-axis, look at that. It exists. It exists. It exists. And you might say, oh, it doesn't exist anymore. Hey, that arrow means it keeps going up forever and ever. So if that's the case, my y's are bigger than 50, right? Because it goes up. But because I make contact there, it's also equal. It is a very loaded question. It has a lot of information that's being asked. Not every question that you have on the homework today will be like this. Okay, let's try it again. So I'm looking at number 4. Use the graph to write an equation of the line, interpret the slope, and tell me the domain and range. All right, so very similar to what we did. Now remember, if I'm going to do this, I'm going to need 2 things. Number 1, I need 2 points. Oh, look at this one right here again. It's a 0. So that's a y-intercept. So then I need the y-intercept, which they gave me. So the b value is going to be 360. All right, big numbers, that's fine. Now let's talk slope, because that's the other thing I need. But when I'm talking about the slope here, I have this point and I have this one only. So look at what we have. I have 0, 360, and we have 6, and then the 0. All right, well, here we go. This is all I need. We're going to draw our little arrows. We're going to head down. All right, here we go with slope. We're going to do a little bit of work to find out. Now, you could do rise over run, but these numbers are a little crazy. It's safer to just use these values on the formula. All right. The y's are first. 360 over 0. So 360 and then the 0. Not over 0, just the 0 next to it. And then 0 to 6 for the x's. 0 to 6. Notice how I didn't change the order. All right, so then my slope is 360 on top and negative 6 at the bottom. Now you have to reduce your fractions. And 360 can actually be divided by negative 6. It's going to work out perfectly. So my slope actually reduces to negative 60 because it is dropping, right? It has to be negative. All right, so I have my y-intercept. I do have my slope, but you know what? They want me to interpret what the slope is. So you know what? Let me take a moment and do that now. Remember, the y's are on top. So when I read the y, it says distance in miles. So it's 360, well, it's miles on top. And then at the bottom, it would be hours. So it's actually miles per hour if you notice. So it's probably a speed and it is travel distance, distance over time. Perfect. That's easy enough. So then when it says negative 60, well, think about it. The distance, don't forget, I'm just using the words that are here. That's all you have to do. The distance decreases. Now I use the word decrease because it is a negative. It's falling, right? It's dropping. Decreases by 60 miles. There it is. Look, miles per hour. There, we have explained what the slope is. Now let's talk about our equation. I kind of paused from that a little bit earlier. Y is equal to mx plus b. Y has to be there. Equals is there. Here comes my slope, negative 60. I put the x next to it. Without it, obviously, it won't represent this line. And my y-intercept was 360 positive, so 360. And just like that, I have my equation of a line. I have interpreted what the slope represents in this line. But they did say, hey, give me domain and range. All right, well, here I go. Domain are the x's. Now notice, there's no arrow here. There's no arrow in this one. So when I'm looking at my x-axis, this graph right here only exists, right? It only exists between 0 and 6. That right there is my domain. I am only allowed to work between 0 and 6. So if that's the case, look, 0, 6, we're talking about x's, so I have to write the letter x. And because I'm only between these two numbers, then I'm greater than 0, but I'm less than 6. And because they're making contact there, we get an equal sign going. Remember, this is the first time we're kind of dealing with domain, so don't stress over it. I'm not even sure if it's going to be assessed yet. So we will look into that, of course. All right, my range are my y's. You know what? I'm going to write the letter y already. But same thing. This is not an arrow where this dot is. So this graph doesn't go up forever. But I see that 360 is the highest it went. And then it dropped. And look at the lowest y value. The lowest y value right here is 0. So it went from 360 to 0. Well then, 0, 360, and now I get to use the same symbols. My y's are bigger than 0, but I'm putting in equals because there's contact. But it doesn't go past the 360, so it's less than 360. And just like that, there's my domain and range. A lot of information there. Okay. Now, it feels like it just keeps going. Remember, welcome to Algebra 2, of course. So let's look at this question. A prom venue charges a rental fee plus a fee per student. The table shows the total cost for different numbers of students at Lakeside Inn. Write an equation of the line that models the information in the table. All right, so they just want an equation of a line. It doesn't change anything. Number one, let's see what we need. The question is, are any of these y-intercepts? Let's see. How do I recognize if something is a y-intercept? Well, let's look up here. Both of these had y-intercepts. How do I know? X was 0, and here, none of them are zeros. Okay. then I don't have an a y-intercept. Then all I need is any random point this time, so a little bit different. So I'm going to pick the one with smaller numbers. I'm going with the 100 and the 1500. So maybe I should have given myself more room. All right, so I chose this point just because the numbers were the smallest there. But now I need a slope. So remember, no y-intercept this time, that's fine. I need a slope. There's my minus signs. Well, look, this one right here was 100 and then 1500. So I need another point. Well, you know what? I'm going to go with the second set of smallest numbers here. So it's 125 and 1800. All right, here we go. There's my little arrows. Y's are first. 1500, 1800. 100 for the X, 125 for the other X. All right, so let's do this very carefully. We subtract the top and I get negative 300. I subtract the bottom and I get negative 25. Well, that does reduce very nicely, but I'm going to reduce my slopes there. The negative divided by the negative, of course, is now going to leave me with a 12. Okay? Now, they only want an equation. They didn't say to do anything else. So my slope is going to be a positive 12 when I divide these two numbers. Okay, now they said create an equation of a line. Well, then let's create the equation of the line. But because they gave me a point, actually they gave me a bunch of them, and they gave me a slope, then I'm going to go with point slope formula. So we haven't used this one yet. All right, point slope is the one that says y minus y1, slope x minus x1. But look, this is how it works. Y minus, put a little equal sign, x minus, and look at that, I left 3 empty spaces. It says for the y value, well, I need another y value. That's my 1500 right there. So I'm going to put my 1500 from the point I chose. I don't need this anymore. All my info I need is here, 1500. I need a slope. Well, look, it was just a 12. So I'll put a 12. And then it says x1. My x1 was 100. Remember, once you decide which point you want to work with, just stick to the information on this side. Oh, sorry, there you go. Now you can see it all. But we're going to stick to the information on this side only. We don't need the table once we made these choices. All right, so sorry you couldn't see that earlier. Now, here we go. Little distribution here. So my numbers are going to get a little big there. But it says y minus 150. We're almost done here. After this step, we'll have one more. 12 times x is 12x. 12 times 100 is 1200. Remember, to have an equation of a line, and we're going to write it in slope-intercept form, we have to get the y by itself. Well, that's very simple. Add the 1500 to both sides, not to the 12x. That wouldn't make sense, but I'll add it here, and just like that, here's my equation of a line. 12x plus 300. All right. Now, what you need to do at this point is you need to try number 6 there, see what you can do. We will be discussing it in class, of course, but I want to make sure you give this a try. Number 6 is very similar to what we just did. So pick 2 points from this list. Let me move this up here now. So it's very similar. So you're going to pick 2 points. Notice, none of these are zeros. So there's no y-intercept. You're going to have to use this form to work this problem out. So I would like you to give it a try. You're just going to write an equation relating to the repayment. So I'm going to skip ahead to number 7. This will be our last one, because then you need to try number 8. This is actually less work than anything else. For number 7 and number 8, they just want me to create an equation that represents, in this case, the number of cookies C. So here's the thing. They want you to use this letter. So they don't want you to use X and Y. Okay? At a coffee shop, cookies cost $1.25 each, and a cup of coffee costs $2.75 each. Write an equation that represents the number of cookies C Amy can buy with $14 when she also buys one coffee. So here's the catch. Amy is going to buy one coffee automatically. Well, remember, one cup of coffee, that's already $2.75. And remember, they didn't say to solve this. They just said write an equation, no solving at all. So if the coffee costs $2.75 for us, right? It says write an equation represents the number of cookies you can buy. The coffee costs $2.75. Now remember, Amy here has $14 to begin with. So whatever we do mathematically here, it has to add up to 14 because that's the only money she has. She doesn't have more to spend. Now, do we know how many cookies she's going to buy? No. We know she's going to buy some cookies, so I'm going to write C for cookie, but she's not buying one cookie, right? We have no idea. And we also know that a cookie costs $1.25 each. So if that's the case, in front of the letter C, I need to write the 125 multiplied by however many cookies she buys, but I still have to add that coffee that she bought. And then we'll figure out how many cookies she can get if she only has $14. But this is all they want from us. They want us to create an equation of a line that I can use to solve for C. They never said to do it. We're just creating an equation. And you do have some problems like that on your homework, on big ideas, where that's all they want you to do. I know I said that was the last one. Let's just practice that one more time. At a donut shop, donuts automatically cost 85 cents each, and a chocolate milk costs $2.45 each. Write an equation that represents the number of donuts C. All right, they just wanted to keep using the same letter that Alex can buy with $5 when she also buys one coffee. Okay. So Alex, she wants to get a coffee, and then we have to find out, well, how many donuts can she get with that amount of money? All right, well, look. We know we have donuts. We're going to think of it a different way. We know that Alex is going to buy coffee, and the only money that Alex has is $5. So the coffee we know is $2.45. So I'll put $2.45 right here. Wait, there's a big bunch of typos there. They're buying chocolate milk. The chocolate milk, we'll say, okay? Or we just change this to coffee. That'll be easier. Anyways, now, donuts. They said the number of donuts C. So we don't know how many donuts that will be that Alex will be able to afford with only $5. But we know each donut is 85 cents. So 0.85 cents, cents C for donuts plus 2.45 will equal the $5. And so just like that, we have our formula for how to find out how many donuts Alex can buy if all Alex has is $5. Now, like I said, number 6, try to give it a try, of course, with the time you have left. And then once you're done with that, we will go over it as a little review when I'm back with you for the next class period. But then again, you have your big ideas right after. So please log in, get into that big ideas, and get that assignment started. Okay? All right. Have a wonderful day, everybody, and I'll see you soon.